So we have two different words, or two different ending to words that we'll need to know. Osmotic and tonic. And do you guys know the difference between these two words? What they're comparing? So they're both comparative words. This one is going to be solutions to solutions. So this could be maybe, what does this solution have in comparison to this one? So maybe this one has 0% salt, and sodium chloride is going to be our salt, and it's an ionic bond. And let's say this one has 10% sodium chloride. And so when you were comparing these, you'd use osmotic at the end of the word to compare those two solutions. Over here, it's going to be cells to solution. And right now, he's dealing mostly with tonic. And so we only have black. So we have our cells in comparison to what solution they're in. And so there's going to be a few different words. So we have saline in the blood. So let's say this is your bloodstream, which is going to be our solution, right? Mm-hmm. And then we have cells in the blood. We have our red blood cells. Normally in your blood, we want to have 0.9% saline. Saline is going to be made of mostly sodium. And so the rule with sodium is that water loves sodium. If sodium's the dog, sodium's the ball, and then water would be the dog. Anywhere we have sodium, the dog's going to get it. Water's always going to be following sodium, no matter what. So, in our blood cells, we want to have 0.9 saline as well. So, this is when we're going to be dealing with how are these two comparing. We're comparing the cells to the solution. So this blood cell to the blood, which is our solution. So right now they're the exact same, right? So that means we'll have no net movement. So this, maybe like 0.1 is coming into the blood, 0.1 water will go back in. No net movement. So that would be an isotonic solution. Iso is just going to be meaning kind of equal. Then, what if, let's say we have our blood cell, and we want it at 0.9%, right? What if, let's say we go to the hospital because we have something wrong with us, and they're going to hook up an IV. So here's our IV coming into our blood, and throw out a number, any number. 10. Let's say we put 10% saline into our blood. Where has the most salt? So remember, saline's made of the most sodium. So let's say, which one has more? 0.9% or 10%? Which is going to be the bigger number for the saline? So 10%. So if we throw the ball over here, where's the water going to go? Where's the dog going to go? It's going to go over here. So what happens is all these H2O molecules, they're our dog. They're like, ooh, I want to come in the blood. Because water loves to follow the sodium. So what's happening here is it's going to shrivel up, right? Because it's losing water. Mm-hmm. So this cell is now going to shrivel. And so basically what's happening is we're dehydrating our red blood cells. Is that going to be healthy for us? No. Nope. So what this is called is going to be a hypertonic solution. So once again, we have tonic. So we're comparing our blood cell to our solution, or our blood cell to our blood. Does that make sense? Mm-hmm. Okay, so then let's do reverse. Let's say sorry. Alright, so here's our blood cell. And then, let's say we have 0.01% saline going through our IV. Which has more sodium? This one?
Yeah.
Alright. So where's our water going to go? So what happens when we're going to load up this one with water? It's going to kind of blow up like a balloon. So I think if this one is going to get bigger, right? So we're going to have the word for this one is hypotonic. Hypo for big. It's a balloon. Because the water is going to want to go into the red blood cell. And that's tonicity. Does that make sense?
Yeah.
Okay, cool. Cool. Another word for, like, you know, when we have the 10% out here and all the water left, and it kind of went like this. Another word for that is going to be crenation or shrivel. So they probably use crenation for it, or it's a hypertonic. When it's big, it's going to lyse, which is another word for burst, or hypotonic. So that one would be a lyse or a burst. This one's crenation or shrivel for hyper. That make sense? Mm-hmm. Okay, let's do one more. Oh, actually, they did a what was it called? What's that vegetable called?
Celery?
It's celery, yes! Wow, I'm surprised you got that. Did they do the celery example yet in class?
No.
Okay, so here's my water. I'm going to have a cool dinner party, and I'm going to feed my guests celery. There's my celery stalks. So, when I want, the question is if I want my celery to be crunchy and make my guests happy, what type of water will I put my celery sticks in? So we're going to be dealing with tonic, because we're talking about the cells within the celery and how they affect, or how the water is going to affect these cells. So, just background knowledge, we're going to want these cells, which one? Do we want them droopy, or do we want them like big and full of water, so we bind them from the crunch? Right, so if we want them full, which one bigger, what type of water would we put in here? So I like to think of it as, where do we want the water to go? We want the water to be going in the celery, right?
Yeah.
So we want the water to be going in the celery. Where do we want our sodium to be? Or where do we want more sodium to be?
So when we want in the celery?
Yeah, because if the sodiums are more saline is in the celery, then our water, which is our dog, is going to follow the sodium. So, in comparison, what would this one be?
You mean like hypotonic?
Yeah,
Oh.
exactly. So we're going to want a hypotonic is what the solution is going to be. So we could say this is just like distilled water or pure water. Because we don't want any sodium here. Because if we had any sodium here, like if we said like we'll put salt water, so maybe it would be like A, pure water or distilled water, B, salt water, C, calcium water. They'll always throw in like a random thing like that you can just throw out. But we don't want sodium in here because we want the most sodium to be in there. So yeah, pure water or distilled water to make a hypotonic solution. And that's about it for tonicity. So what is it called when it's equal? Let's say we have 0.9 in the cell.
The yeah.
Isotonic.
Oh.
So, isotonic, iso equal, I don't know. Isotonic. Any questions? Cool. No more. Does that make sense?
Mm-hmm.
Okay. That's one of the harder concepts to kind of grasp. But once you grasp it, it kind of makes life easier. So water always follows sodium. That's going to be a principle that's going to hold true throughout the entire semester. So if we're ever talking about like the cell and stuff, what's passing through it, what's kind of coming out, water's always going to follow that sodium.